I'm going to show you some divisibility rules, so that way it will help you with writing out factors and multiples. Here's an example of one. So divisibility by 5. A number is divisible by 5, and if you notice the pattern here, look, it's basically like counting by 5s. Now look at, what do all these numbers end with, right? If I keep counting by 5s, they end in either a 5 or a 0. That's always going to be true. So if a number is divisible by 5, you'll know it by looking at the ones place. And in the ones place, you'll know if it's a 0 or a 5, you could divide it by 5. Which means, for example, if I had a number like 10,450, I know this is divisible by 5 because it ends in a 0, because the 0 is in the ones place. And I also know, for example, that if I had a number like, let's say, 1,244,562, is not divisible by 5 because the ones place ends in a 2, and it needs to end in a 0 or a 5. And then the last example, if I had a number like 10,245,376,155, then this is divisible by 5 because, again, there's a 5 in the ones place. So this is the divisibility rule for number 5. So a number is divisible by 5 if it ends in a 0 or a 5. Here's another one. This is divisibility by 10. If you were to count by 10s, these are all going to be numbers that are divisible by 10. So 10, 20, 30, 40, 50, ... right? And you probably notice, similar to the divisibility rule for 5, it's similar to the divisibility rule for 10s. Notice that all in the ones place ends in a 0. So if your number ends in a 0, you know it will be divisible by 10. Here's the next one, divisibility by 2. You'll know a number is divisible by 2 if you look at, for example, the multiples. Look, 2, 4, 6, 8, 10, 12, 14, 16. If you continue that pattern, you'll notice that all the numbers are even, right? 2, 4, 6, 8 are even. Notice the ones place, 0, 2, 4, 6, and if I did 18, 20, you're going to see it's going to repeat that pattern. So a number is divisible by 2 if it ends in an even number. In other words, there's an even number in the ones place. So for example, if I had a number like 77, it's not even because it needs to end in a 0, 2, 4, 6, or an 8, and this is a 7. Therefore, I cannot divide this by 2. And remember, when I say divisible by 2, it means it has to be a natural number. You don't get a decimal. Like if I were to divide this by 2, I get a decimal. To be divisible, you should not get a decimal. It should be a natural number. And as a side note, a natural number would be something like 1, 2, 3, 4, ... So that's what when I say it is divisible, it has to be a multiple, like of a natural number and another one. So that's what it means to be divisible. Another one would be like if I had 102. That's divisible by 2 because it ends in an even number. It's in the ones place. If I had a number like 1001, it's not divisible by 2 because there's not an even number in the ones place. And so on and so forth. So this is the divisibility rule for 2s. It has to end in an even number. In other words, there has to be an even number in the ones place to be divisible by 2. And here's a divisibility rule for 3s, which comes in handy when you get to really big numbers. But a number is divisible by 3 if the sum of the numbers that makes up the number is divisible by 3. So that might sound kind of confusing, but let me just show you an example. Let's look at the number 15. If you take these two digits and add them together, I get the number 6, right? When I say add them together, so 1 plus 5, when I add these together, I get 6. And I know that 6 is divisible by 3 because 3 times 2 is 6. And since 3 divides into the sum of these two, I know 3 could go into 15. So if you know your multiplication facts, you don't really need to know this rule, but it comes into play, I notice, when it comes to like really big numbers. So 1, 1, 4, 3, I could tell that this is divisible by 3 because if you were to add all these digits together, 1 plus 1 is 2, 2 plus 4 is 6, and 6 plus 3, you get 9. So again, in my head, I'm just adding these digits together. I get 9, and I know 9 is divisible by 3. Therefore, you could divide 3 into the number 1143. So 1143 is divisible by 3 because of that idea there. So that's another rule you can use. So if you have a really big number and you're trying to reduce a fraction, for example, and you want to check for divisibility by 3, just look at the sum of their digits. and you'll know it's divisible by 3. And here's an example, another example. So if I had something like 1, 0, let's see, 2, 1, if I were to add these digits together, 1 plus 0 is 1, plus 2 is 3, plus 1 is 4. And since the sum of these numbers is 4, 3 and 4 is not divisible by 3, then I know 3 cannot divide into this number. And that's the rule for divisibility by 3.